Hello, welcome to the third day in the 7.2. We're going to continue with the lesson where we left off the previous day. And now we're going to work with the formulas that we learned about yesterday, we're going to use today. And today gets a little tricky. Now suppose x is normally distributed with a mean of 50 and a standard deviation of 8, and y is normally distributed with a mean of 30 and a standard deviation of 6. Let's say these guys are playing darts, and the first person averages 50 with a standard deviation of 8, and the second person averages 30 with a standard deviation of 6. What's the probability that both of them together will get over 95? So the probability that x plus y is going to be over 95 is the probability that their z-score is going to be over a particular value. So we need to find the z-score. Before we find the z-score, we need to find the mean of x plus y, and we need to find the standard deviation of x plus y. Well, we learned previously that the mean of x plus y is just x plus the mean of y, which will be 80. That's nice and easy. Now, but to find the standard deviation is a little bit more difficult. What we have to do is take 8 squared to find the variance, plus 6 squared to find that variance, add them together, and square root it. So this is 64 plus 36, which is 100. Square root of 100 is 10. So I have a normal function where the mean is 80 and the standard deviation is 10. So I want to find out if it's greater than 95. So that would be over in the corner here somewhere. And so the probability this happens is 95 minus 80 over 10, which is the probability my z-score is greater than 15 over 10, which is 1.5. So I do normal CDF from 1.5 to a very large number, and that's 0.0668. 0.0668. So that's about 6.68% chance that that couple is going to get over 95. Well, what's the probability that x will be y? That's pretty. You can tell just by the data that there's going to be a high probability because this guy averages more than the other person. So the probability that x gets more points than y. Now we can't do this with z-scores because there's not a number over here. So we have to do some algebra, subtract y on both sides. So what's the probability x minus y is greater than 0? Now we can do this. Now we have to find the mean of x minus y and the standard deviation of x minus y. Well, the mean of x minus y, we just take mean of x minus mean of y, which will be 20. The standard deviation of x minus y is going to be the same thing as standard deviation of x plus y. One number squared plus the other number squared and square root it. So that would be 10. So we do the problem again with a new mean of 20, and the standard deviation is still at 10. And we want to find the probability that it is greater than 0. Greater than 0 is over here. So that's pretty likely. There's a pretty good chance that this is going to happen. But to figure out the z-score is going to be 0 minus 20 over 10. So that's going to be the probability that my z is greater than negative 2. So if I do a normal CDF from negative 2 to infinity, I'll get 0.9772. So there's about a 97.72% chance that my first dart thrower will beat my second. All right, just to make sure I got them all. Good. So my next situation, suppose the time in hours required to assemble a computer is normally distributed with a mean of 6 and a standard deviation of 1.2. And the time b in hours required to box it and get it on a truck is also normally distributed with a mean of 2 and a standard deviation of 0.5. And assume that each task is independent of each other. We want to find each of these three cases. What's the probability that the entire process will take more than 10 hours? Now, what that is going to do is that's going to find the probability that x plus y is greater than 10. So that's going to be the probability that I didn't need a parentheses there. I'll turn that into a y. That's going to be the probability that my z-score is greater than 10 minus my mean over the standard deviation. So I need to find my mean of x plus y, my standard deviation of x plus y. My mean of x plus y is the mean of x. I should be saying a and b. Let's change that real quick to an a and b, because that's how the problem states it. The mean of a plus the mean of b will give us our new mean. So let's go back to that. So it's 6 and 2. So 6 plus 2 is 8. That's our new mean. Our standard deviation, we have 1.2 and 0.5. So I'll get this by taking 0.5 squared plus 1.2 squared and add those up. That's 1.69 square rooted. That'll be 1.3. So I'm finding the probability that my z-score is greater than 10 minus 8 divided by 1.3. So that's my probability. My z-score is greater than 2 over 1.3 is 1.54. So that's going to be a normal CDF of 1.54 to a very large number, which is 0.06178. So about 6% of the time, it'll take more than 10 hours. The second question asks, what is the probability it takes less than 15 hours to assemble 3 computers? Now this isn't 3x or 3a. What this is the probability that a plus a plus a is going to take less than 15 hours. So to do this, what we want to do is find the mean of a plus a plus a, and that's going to be 6 plus 6 plus 6, which is 18. And we need to find the standard deviation of a, which is the square root of 1.2 squared plus 1.2 squared plus 1.2 squared. Or we could have just said 3 times 1.2 square root of 3 times 1.2. And that's 2.02. So the probability that this is less than 15 is the probability my z-score is less than 15 minus 18 over 2.02, which is the probability my z-score is less than negative 3 over 2.02, which is negative 1.48. So I do a normal CDF of negative 1.48 to a very large number, and that probability, ooh, wait, I'm doing the probability that's less than. So let's do this again. Normal CDF from negative very small number to negative 1.48 is going to be 0.0694. Now the next one was the probability that the crew could assemble a computer quicker than it could box and load 2 computers. So that's the probability that it can assemble a computer quicker, so that's in less time than it takes to box and load 2 computers. So that's the probability that x minus y is going to be less than 0. So I need to find the mean of x minus y and my standard deviation of x minus y. So my mean is going to be 6 minus 2 minus 2, which is 2. To find my standard deviation, I take 1.2 squared plus 0.5 squared plus 0.5 squared and square root those. So 1.2 squared plus 0.5 squared plus 0.5 squared, square root those values, and I'll get 1.393. All right, now to find this, it's going to be the same probability that my z-score is less than 0 minus 2 over 1.393. So that's going to be negative 2 over 1.393 is negative 1.435. It's probably my z-score is less than negative 1.436 maybe. And so I do a normal CDF from negative big number to negative 1.436, and I get 0.0755. So there's about a 7.5% chance that they can assemble a computer quicker than loading it on and boxing it on the trucks. All right, here, let's take a look at the rules. Now the rules, if I'm doing a linear transformation, I just take a plus b times the mean of x, and when I'm doing two events, I add the mean of x plus the mean of y. For the variance, if I want to find the new variance, if it's just a linear transformation, I take b squared times my previous variance, and if I'm adding or subtracting two random variables, I still add the variances. All right, any linear combination of independent normal random variables is also normally distributed. All right,